Today in this video, I am going to discuss about the power in AC circuit. Already I have discussed the different types of the AC circuit, like with the circuit containing pure resistance, pure inductance, perfect capacitor, LR series circuit, CR series circuit, and LCR series circuit. And already I have given also how can we find the impedance of the different types of the circuit here. Now here, power in AC circuit. Actually, the power is what here? The rate of dissipation of energy in an electrical circuit, or the rate of dissipation of energy in an electrical circuit is called its power, and it is a product of voltage and current. If the voltage is measured in volt and current is measured in ampere, then the power will come in watt. And here, how can we calculate the power in AC circuit? Even you know in the DC circuit already I have given the different formula for calculating the power, like P is equal to VI, P is equal to V square by N. But how can we calculate the power in AC circuit? AC circuit means when there is a phase difference between the voltage and current. So let the alternating voltage and current is given by the equation P is equal to V naught sin omega t. As you know, V is the instantaneous voltage. It means if the instantaneous alternating voltage is given by V is equal to V naught sin omega t, and instantaneous alternating current in any circuit is given by I is equal to I naught sin omega t minus phi. It means here I want to take the power dissipation in that circuit or power in that AC circuit in which there is a phase difference between the voltage and current. And here the phase difference between the voltage and current is how much here? Phi. It's not matter this phi is lead or lags, but the phase difference between voltage and current is phi. And already I have told you how can you find the phase difference between the voltage and current. Simply you will take what first? Argument of sign here, and take the difference of the argument of sign, then you will get the phase difference between the voltage and current. So voltage, this one instantaneous voltage, instantaneous current. And when you will take the product of voltage and current, then you will get the instantaneous power. And that instantaneous power, you can write here I and S. That instantaneous power is equal to V into I. And at place of V, you can write V naught sin omega t into, at place of I, you can write I naught sin omega t minus phi. I naught sin omega t minus phi. And now you can write here V naught I naught sin omega t. This one is sin omega t. And here sin A minus B. When you use this one, sin omega t minus phi means sin A minus B. There is formula sin omega t cos phi minus cos omega t sin phi. This is the formula. And I want to tell you here, this now what formula I am using here is sin A minus B. Here write down here. Sin A minus B is equal to sin A cos B minus cos A sin. This is the trigonometrical formula, and that formula I am using in the case of sin omega t minus phi. So suppose omega t is A, phi is B. So you can write sin omega t minus phi, sin omega t cos phi minus cos omega t sin phi. And this is equal to, you can write V naught I naught. Now take this sin omega t inside here. So when you will take sin omega t inside, so sin omega t here, already sin omega t, you can write here sin square omega t cos phi minus sin omega t cos omega t minus sin omega t cos omega t, and this one is sin phi. Simply take this sin omega t inside, multiply in both. So this becomes sin square omega t cos phi minus sin omega t into cos omega t into sin phi. And one more step here, we can write here V naught I naught Here sine square omega t cos phi minus here sine omega t cos omega t. Here divide by 2 into multiply by 2. Divide by 2 and multiply by 2. So you can say there is no any effect in this one, and you can write here 2 sine omega t cos omega t, and this one is sine phi. Simply यहाँ 2 से डिवाइड करके और 2 से मल्टीप्लाई कर दीजिए. Why I am doing like this? ऐसा क्यों कर रहे हैं? Because there is a formula 2 sine A cos A. This one is R2 sine omega t cos omega t is equal to sine 2 omega t. This is the formula. Sine 2 theta is equal to 2 sine theta cos theta. So now at place of 2 sine omega t cos omega t, we can write sine 2 omega t. So instantaneous power is equal to V naught I naught here sine square omega t cos phi minus 1 by 2, and at the place of 2 sine omega t cos omega t, ये फार्मूला है किसका? sine 2 omega t and ये sine phi. If you want, then you can write since sine 2 theta is equal to 2 sine theta cos theta. This is the formula. And here at place of theta, omega t. So sine 2 omega t is equal to 2 sine omega t cos omega t. Now you see here. So instantaneous power in the AC circuit will come V naught I naught sine square omega t cos phi minus half into sine 2 omega t and sine phi. But for one complete cycle of AC, one complete cycle of AC, the average value of sine square omega t is equal to 1 by 2. But for one complete cycle of the AC, the value of sine 2 omega t is equal to 0. So for one complete cycle of AC, sine square omega t की वैल्यू होती है 1 by 2 and sine 2 omega t its value is equal to 0. For one complete cycle of the AC, at the place of sine square omega t and sine 2 omega t, we will write this value here. So hence, चूंकि इसकी जो एवरेज वैल्यू है वन कंप्लीट साइकिल के लिए वो होती है हाफ. So hence the average power in AC circuit, now this instantaneous power becomes average power. Why? Because the average value of sine square omega t in one complete cycle is how much here? Half. And sine 2 omega t is 0. So you can say here average power P is equal to, you can write here V naught I naught. At place of sine square omega t, you will write here 1 by 2 and this one is cos. While sine 2 omega t is 0, so whole this term becomes what here? 0. So you will get only V naught I naught into 1 by 2 cos phi. Or simply you can say 1 by 2 V naught I naught cos. So this average power can also be written as, at place of half, we can write here V naught by root 2 into I naught by root 2. Means at place of 2, you can write root 2 into root 2. So root 2 into root 2 is what here? 2. And V naught I naught is already here, V naught I naught. And here you can write into cos. And at place of V naught by root 2, already I have given the formula. What can you write? V, R, and S. And at place of I naught by root 2, you can write I, R, M, S. And into cos. It means the power in AC circuit in one complete cycle is given by P average, or the average power in AC circuit is given by VRMS into IRMS into cos phi. So the average power in AC circuit, for one VRMS into IRMS into cos phi. The term cos phi is called power factor. Cos phi is called power factor. And look here, whole this term cos phi is called power factor, not phi. इसमें phi नहीं power factor, पूरा term जो cos phi की जो value होगी उसको कहते हैं power factor. So whole this cos phi is called what here? Power factor. And the value of cos phi for any circuit R by Z. हमने कल बताया था impedance triangle, and in that impedance triangle, if you remember, I was given this diagram. This one is R, this one is XL minus XC, and this one is Z. And here this phi. So from here you can say cos phi is equal to this upon hypotenuse. You can write R by Z. Where R is the resistance of that circuit and Z is what here? Impedance of the circuit. जैसे हम ले लें LR सर्किट, तो LR सर्किट के लिए रेजिस्टेंस और LR सर्किट का जो इंपीडेंस होगा वो यहाँ लिखेंगे. That ratio is whole. This ratio is called what here? Power factor, which is equal to cos phi. So this expression can also be written as P average or average power is equal to VRMS into IRMS into at base of cos phi is equal to R by G. Now, several times this question we asked. If anybody asks to you, if the circuit contains pure resistor, अगर circuit में pure resistor हो, तब power कितना होगा? So when circuit contains pure resistor, so at that time the phase difference between the voltage and current is zero. It means both voltage and current will lies in same phase, and when both current and voltage lies in the same phase, means the phase difference between them is zero. So when the circuit contains the pure resistance, then at that case phi is equal to 0, and in that case cos 0 is equal to 1. So how much the power in AC circuit when it contains only resistance? That one is equal to P is equal to PRMS into IRMS. One more thing which I want to tell you here. Several times this question is asked. What is the power factor of LCR circuit in resonant condition? Our aim is to find power factor of LCR circuit in resonant circuit or in resonant condition. In resonant condition. In study video हमने कल बताया था कि रेजोनेंस कंडीशन में LCR सर्किट का इंपीडेंस किसके बराबर होगा? फर्स्ट यू रिमाइंड कि व्हाट इज द फार्मूला फॉर द इंपीडेंस ऑफ LCR सर्किट. हमने क्या बताया था? Z इज इक्वल टू R स्क्वायर प्लस XL माइनस XC. ये बताया था. एंड फॉर रेजोनेंस कंडीशन XL इज इक्वल टू XC. तो इन रेजोनेंस कंडीशन the impedance of LCR circuit Z is equal to R. And in resonant circuit condition, our aim is to find the power factor. And you know power factor is equal to, power factor is cos phi, which is equal to R by Z. And in resonance condition, what is the Z for LCR circuit? Z is equal to R. You can write R by R, which is equal to 1. It means you can say cos phi equal to 1. Always remember this. The power factor of LCR AC circuit in resonance condition is how much here? 1. ये मत सोचिएगा कि cos phi is 1 तो phi is equal to 0 degree. डिग्री में नहीं होता पावर फैक्टर. पावर फैक्टर पूरा टर्म है. ये cos phi पूरे टर्म की जो वैल्यू होगी cos phi की, वो है पावर फैक्टर. And that value you are getting here 1. It means the power factor of LCR circuit in resonance condition is how much here? 1. Now one term is also here, wattless current. I hope maybe now this time this wattless current is not mentioned in your syllabus, but please you listen here only 1 minute definition here. Wattless current क्या? If the resistance in the circuit is absent, if there is no resistance in the circuit, even the current flows in the circuit, but the power loss is equal to 0. Such type of the current is called what here? Wattless current. हमने क्या कहा In the absence of resistance R, if there is no resistance in the circuit, even the current flows in the circuit is called, even the current flows in the circuit, but the power loss is equal to zero. And that current is called what here? Wattless current. जैसे हम कहें circuit contains pure inductor, तो वहाँ करंट तो फ्लो हो रही है, और प्योर इंडक्टर के केस में क्या होगा? फेज डिफरेंस बिटवीन करंट एंड वोल्टेज 90 डिग्री, and when you put in the formula then cos 90 is equal to 0, then power becomes 0. तो in this case सर्किट में करंट तो फ्लो कर रही है लेकिन पावर का लॉस नहीं हो रहा है, तो ऐसे करंट को क्या नाम दिया गया है? वॉटलेस करंट। जैसे हम लोग कभी कभी कह देते हैं 0 वाट का बल्ब, तो 0 वाट का बल्ब थोड़ी होता है, उसमें कुछ ना कुछ पावर का क्या होता होगा? लॉस होता होगा। एंड जनरली in the tube light we use the choke coil, and the purpose of the choke is what here? To minimize the loss of electrical energy. वो electrical energy के loss को क्या करता है? choke coil minimize कर देता है। So this is simply the what here? Wattless current and about the choke coil. Now next one more factor which I want to tell you about, the quality factor. Actually the quality factor is sharpness of resonance, and it is given by the formula, the quality factor of LCR series circuit is given by Q is equal to, quality factor is denoted by Q is equal to 1 upon R root L by C. तो ऐसा है पूरी, जैसा मैंने बताया क्वालिटी फैक्टर है क्या? क्वालिटी फैक्टर इज द शार्पनेस ऑफ रेजोनेंस, and it is given by, for LCR series circuit the quality factor is given by Q is equal to 1 upon R root L by C. And how can we increase the quality factor? Quality factor कब बढ़ेगा? जब R को घटा दे, C को घटा दे, या L को क्या करें? बढ़ा दे। तो in this way you can increase the quality factor of LCR series circuit. So next topic which already you know, about the transformer here. So today you go through this topic here, what I have discussed here. Even this one is very small topic here, and please also read about the transformer because already you have studied in the class 10. But tomorrow I will give you a short video for the transformer, and also you solve the numerical problem of this exercise. Thank you.